In this video, we'll go over the PSAT questions from Chapter 6 and some mixed reviews from previous chapters. This first one, we're told that BC and AD are parallel, and we're also told that AB and EC are parallel. And they tell us further that CD and CE are congruent. So since this is a parallelogram here on the left, this figure here, we can make certain conclusions. There's a 115 angle over here across, and consecutive angles are supplementary. So this one is going to be 65 degrees, and this is also 65 degrees. We also know that this triangle over here is isosceles, because two of the sides are congruent, which means that the base angles down here are going to be congruent. So a linear pair, this would be 65 degrees, because the two angles have to add up to 180. And since this is the other base angle, it's also 65 degrees. Finally, we can use the sum of the interior angles of a triangle, 180, to figure out this missing angle. So 65 plus 65 is 130. If I subtract that from 180, I get 50 degrees. So 65 over here plus 50 over here, the answer is 115. So by vertical angle, this is congruent to angle 1, so it's also 35 degrees over here. And if we consider this shape a parallelogram, which we can based on those properties listed below, this angle here is also 35 degrees. And so would this one be. And we could remember this by transversals and that cross parallel lines as well, the whole consecutive interior angles or exterior angles or that sort of thing. But this new method with parallelograms works also. Consecutive angles here are going to be supplementary, so I take 180 minus 35, and that's where I get the 145 degrees, D. So I have a square here with a diagonal, and a property of squares is that the diagonals are perpendicular to each other. So if I can find the slope of the one diagonal, which is given to me, well, they give me two of the points anyway, they give me C and E, all I need to do is figure out the slope. So 0 minus 2 over 1 minus 7. That's one way to do it. And I get negative 2 over negative 6, which translates to 1/3. So if I want to flip this and make it negative, my new slope is going to be negative 3 over 1. So that means these are wrong, and it's either A or B. From there, I can figure out what my intercept might be. Now, if I just kind of eyeballed it and said, this is my line, this is the other diagonal, it's not going to be negative 3 distributed negative 1 plus 3, is it? Well, actually it is. Yeah, there it is, right there, positive 3. And the other one will be down here at negative 1, and we can see that it's not down there. So that means that B is going to be the best answer. So L and M are parallel, which means that this is considered a transversal, so the corresponding angles down here 20 degrees matches up with up here 20 degrees. They tell us that Z is 60, so here I just take 180 minus the known angles to figure out that X is equal to 100 degrees. They tell us line L has a slope of 3, and line K is parallel to that. Since it's parallel, the slope is going to be 3. So that rules out these two, because we got to see that 3 right there. So given this point, I can plug into the equation y equals mx plus b. I'm going to put 10 in for y, I'm going to put 3 in for my slope, and 3 in for my x coordinate. And this gives me that 10 is equal to 9 plus b. So if I subtract 9 from both sides, b is equal to 1, which means that D is my answer. This one is about a student walking and what's the total distance. So they go from P over to Q, so they go 1, 2, 3, 4, and then they go up 1, 2, 3, 4, 5, 6, 7. So 4 and then 7. And according to this scale, every 2 is a kilometer. So if they traveled 11 total, I divide that by 2 and I get 5.5. C. So the formula for area of a parallelogram is the height times the length here. So I'm going to take 5 times 10, and the answer is 50. The idea is that this little triangle over here could actually be moved and fit exactly there, so it's pretty much just a rectangle. I'm given a couple coordinates and I have to find the slope. So let's take 4 minus 1 all over negative 1/2 minus negative 5/2. So minus and a minus is going to be plus. So on the top I have 3, and on the bottom I have negative 1/2 plus 5/2, so that ends up being 4/2, which is just 2. So 3 over 2, D. So here's a graph, and the graph of the linear function g, not shown, is perpendicular and passes through a particular point 1, 3. So it passes through this point, and it's perpendicular. So I can find the slope of f. It's going down 2 and right 1. So I could just write that slope as negative 2. I could also use the coordinates and figure it out. Perpendicular to negative 2 means it's positive 1/2. But they want to know what happens when you plug in 0. So I do have to figure out the b value. To do that, I'm going to use this point here and this slope here. So 3 for my y value is equal to my m value, 1/2, times my x value, 1, plus b. So 3 is equal to 1/2 plus b. 2.5 is equal to b. And that is actually my answer here, because the value of g of 0 means when I plug 0 in, what do I get for y? Which is the same thing as my y-intercept. So the answer is 2.5. The problem with this line is that it's written in standard form. So you could identify the intercept, the b value, as negative 4. And if you looked at some of the points, you can figure out that m is negative 1 here. And you could write an equation. You could say that y is equal to negative x minus 4. And if you look at what's up here, we're going to have to add x to both sides, and we get y plus x is equal to negative 4. Or x plus y is equal to negative 4, and the answer is C. Of course, you can do that a different way. You can also just plug in zeros. So when I plug in 0 for x, I should get a negative 4. Let's see if that happens here. I could plug in zeros for certain values, and it would have to be, that would rule out these two. And on the flip side, if I plug in something for x, like negative 4 here, I'm going to get a 0 for y. And that would lead you towards C.